Bismillahirrahmanirrahim. Welcome dear students of first year MBBS, BDS and DBT. Today's lecture is about the cardiac cycle. After studying this lecture, you will be able to explain various phases of cardiac cycle. You can also explain the various pressure changes that occurs in the atria, ventricles and aorta. And at the end of this lecture, you will also be able to solve concept check questions at the end. Cardiac events that occurs from beginning of one heartbeat to the start of next heartbeat are called cardiac cycle. These events occurs in two phases. Diastole and systole. Diastole means the period during which ventricles relaxes and fills with blood. Systole means the period during which ventricles contract and pump blood out of heart. From right ventricle, blood is pumped into the lungs for oxygenation. From left ventricle, blood is pumped into the aorta and systemic circulation. Each cardiac cycle is initiated by spontaneous generation of action potential in the SA node. Then from SA node, wave of depolarization spreads into the atrial muscle. Then atrial muscle contracts and wave of depolarization spreads from AV node, AV bundle, and Purkinje fibers into the ventricles, and after that the ventricles contract and pump blood. The normal duration of cardiac cycle is 0.833 seconds. This duration is the reciprocal of heart rate. Means if heart rate increases, duration decreases. If heart rate decreases, duration increases. For example, if heart rate is 72 beats per minute, then we can calculate duration of the cardiac cycle from this heart rate as following: 1 divided by 72, this comes 0.0139 minutes per beat are 0.833 seconds per beat. As we mentioned, the cardiac cycle, it occurs in two phases, diastole and systole. And because the atria and ventricles do not contract and relax at the same time, we discuss atrial and ventricular events separately. And the ventricle and atrial events during the cardiac cycle, they begins with the filling of the ventricles. That is called the filling phase. After filling phase, that occurs in two ways: rapid filling and slow filling. After this, 80% of blood, it moves into the ventricles. After rapid and slow filling, atrial systole occurs and atria contracts and pours remaining 20% of blood into the ventricles. When the ventricles are full of blood and after atrial systole, AV valves closes. When AV valves closes, the pressure starts increasing in the both ventricles, right and left ventricles. In both ventricles, pressure increases, and with the closure of atrioventricular valves, the next phase begins, that is called isovolumic contraction. As we mentioned, during this phase, all the four valves are closed and the pressure builds up in the ventricles. And when this pressure exceeds the pressure in the aorta, then the next phase begins, that is called ejection phase. And during ejection phase, the blood is pumped from the right ventricle through pulmonary valve into the lungs, and from the left ventricle the blood is pumped through aortic valve into the aorta and then into the systemic circulation. When ejection phase is complete, then again all the valves they become closed and the ventricles basically they relaxes. When the ventricles relaxes, then again starts the next phase, that is called the filling phase. And before filling, when the ventricles are relaxing, that phase is called isovolumic contraction. During systole and diastole, right ventricle receives deoxygenated blood, while left ventricle it receives oxygenated blood. Mitral and tricuspid valves that are present between the atria and ventricles are called atrioventricular valves, while the valves present between left ventricle and aorta and the right ventricle and pulmonary arteries are called semilunar valves. All four valves open when pressure on the upstream exceeds pressure downstream. The atrioventricular valves closes when ventricular pressure increases, while semilunar valves close when forward flow in the pulmonary artery and aorta ceases. In thinking about blood flow during cardiac cycle, remember that number one, blood flows from an area of high pressure to area of low pressure. Number two, contraction increases pressure, while number three, relaxation decreases pressure. We enter the cardiac cycle at the brief moment during which both the atria and ventricles are relaxing. The atria are filling with blood from veins and ventricles have just completed a contraction. So, after contraction, the first phase that appears in the cardiac cycle uh, is isovolumic relaxation. During this phase, ventricles relaxes. When they relax during this phase, the pressure in ventricles falls. When pressure in the ventricles falls, due to that fall in pressure in the ventricles, then the superior and inferior vena cava and the pulmonary veins, the filling of the ventricles starts. And that filling occurs in three phases: early phase and later phase. Early phase is also called rapid phase, while the later phase is called slow phase. During rapid phase, 70% of filling occurs. through atrioventricular valves. Then comes the slow phase, that is also called diastasis, and during this phase slow filling occurs, and due to that slow filling another 10 to 15% of blood enters ventricles. During rapid and slow phase, the ventricles they expand to accommodate blood that is entering the ventricles. After rapid and slow phase, atrial systole begins, and during atrial systole, 20% of filling is accomplished when atria contract and push blood into the ventricles. When atria contracts and they push blood into the left and right ventricles, then after this phase all the valves closes and isovolumic contraction begins. It begins isovolumic contraction. It begins as spiral bands of muscles squeeze the blood upward towards the base, and when they squeeze the blood towards the base, this closes AV valves, and when AV valves are closed, this marks the beginning of isovolumic contraction phase. When the pressure during isovolumic contraction it becomes more than 80 mm of mercury, that marks the opening of semilunar valves, and ejection phase begins. Ejection phase occurs in two steps: rapid ejection and slow ejection. Rapid ejection is basically shorter phase, while the slow ejection is longer phase. And during ejection, the blood is pumped out of the ventricles into the systemic arteries and also into the pulmonary arteries. So during systole and diastole, six events occurs that we will discuss one by one in the coming slides. The first event is the pressure changes in the left atrium and right atrium. Then the second event is pressure changes in the aorta, and then is the pressure changes in the left ventricle, and also in the right ventricle the same changes occurs. Then the volume changes in the left ventricle, and the fifth change is production of heart sounds, and the sixth is the electrical changes that occurs during the cardiac cycle. So the first change or the event that occurs during cardiac cycle is the pressure changes in the atria and their role as primer pumps. As discussed, blood flows from atria into the ventricles through great veins. About 80% of filling occurs during rapid and slow phase, even before atrial depolarization begins. When atrial depolarization begins, as we discussed in the previous slides, when atrial depolarization occurs, atrial systole means contraction occurs, and due to this contraction, 20% remaining amount of blood, it also enters the ventricles. At rest, heart can continue to operate under most conditions without this 20% extra amount, because heart pumps 300 to 400% more blood than is required at rest. Therefore, when atria fails to contract, the symptoms appears only when the person moves for exercise. Then the acute symptoms of heart failure appears. When all these events are happening in the atria, certain pressure changes occurs in the atria. That changes in the atria appears in the form of waves, in the form of three waves. Number one, A wave. Number two, C wave. Number three, V wave. The first wave is A wave. A wave is caused by atrial contraction, and during this phase, atrial contraction phase or atrial systole, right atrial pressure rises up to 4 to 6 mm of mercury, while the left atrial pressure rises up to 6 to 8 mm of mercury. Then is the second wave, that is C wave. It appears when ventricles begin to contract and it also partly appears by the backflow of blood into atria. When ventricles begins to contract, this blood flows back towards the atria. The third wave is V wave. V wave appears, as you can see from this diagram, it appears towards the end of ventricular contraction. Due to slow flow of blood and due to slow flow of blood into the atria while AV valves are closed towards the end of ventricular contraction. The second event that occurs during cardiac cycle is the pressure changes in the left ventricle. The discussion of pressure changes in the left ventricle starts with the atrial systole. During atrial systole, as we have discussed, 20% of blood enters into the left ventricle. At the same time, small amount of blood also moves into the veins as there is no valves between the atria and the veins, and this appears as pulse in the jugular vein. When atrial systole is complete, the atrioventricular valves closes. Semilunar valves are already closed, and this marks the start of isovolumic contraction phase. During isovolumic contraction, the wave of depolarization spreads from atria to ventricles. During this phase, left ventricle pressure rises. Contraction occurs, but no emptying is there because all the valves are closed. That's why this phase is called isovolumic contraction or isometric contraction. It is so called because tension increases during this phase, but there is no shortening. So, additional 0.022 to 0.033 second is required to build up pressure during this phase to overcome the pressure in the aortic valve, that is 80 mm of mercury. When this pressure is achieved and when ventricular pressure exceeds 80 mm of mercury, then the aortic valve opens at this point, and this marks the beginning of ejection phase. Ejection phase, as we have already discussed, it occurs in a rapid and slow manner. Rapid is short phase and it comprises the 1/3 of ejection phase, while the slow phase, it is longer phase and it contains 2/3 period of ejection phase. During rapid and slow ejection, around about 80 to 90 milliliter of blood is pumped out of the ventricle. A rapid phase differs from slow phase by number 1, sharp rise in aortic and ventricular pressure occurs. Number 2, a more abrupt decrease in left ventricular volume occurs in a rapid phase. Number 3, a greater aortic blood flow occurs. During rapid phase. During 1/3 of ejection, that is a rapid ejection, ventricular pressure exceeds pressure in the aorta. During the last 2/3 or slow phase, reverse occurs, and this reversal in the presence of continued flow to the aorta is caused by momentum of forward blood flowing into aorta. And this momentum of forward blood flowing into the aorta, it results from storage of potential energy. So during rapid ejection, as we have mentioned, the pressure rises and it becomes 120 mm of mercury. During the slow phase, the pressure decreases, but due to momentum, the blood continues to flow into the aorta. But the pressure in the left ventricle starts decreasing. When it decreases to 80 mm of mercury, then aortic valve closes at this point, and that marks the start of isovolumic contraction phase. That marks the start of isovolumic relaxation phase. As we have seen, during this phase, again all four valves are closed, pressure decreases in the ventricles, and when this decrease, it becomes when this decrease it becomes less than the pressure in atria. Atrioventricular valves opens, and that marks the start of filling phase. The first phase of filling is the rapid filling. Onset of rapid filling is indicated by the decrease in left ventricular pressure below left atrial pressure. As we have mentioned, this opens AV valves, and the opening of AV valves allows blood to flow into ventricles. This rapid flow of blood from atria to relaxing ventricles produces two effects. Number one, decrease in atrial and ventricular pressure. Number two, sharp increase in ventricular volume. During a rapid filling, major portion of the ventricles is filled with blood, and almost this amount is 70%. After rapid filling, slow filling occurs, that is called diastasis. During diastasis, blood flow from periphery to right ventricles and from pulmonary arteries through left atrium into the left ventricle. This phase is indicated by a gradual rise in atrial, ventricular, and venous pressure. Number 2, increase in ventricular volume. When ventricular pressure increases and it approaches 80 mm of mercury, at this point aortic valve opens, ventricular pressure increases much less than, because blood flows out into the aorta and systemic arteries. This causes walls of arteries to stretch and pressure increases to 120 mm of mercury. At the end of this rapid rise in pressure during rapid ejection, slow ejection starts and ejection phase ends. When ejection phase ends, after that the left ventricle stops ejecting blood and aortic valve again closes, and this marks the appearance of notch that is called incisura. This appears because of backflow of blood immediately before closure of valves towards the left ventricle. When the aortic valve closes, the pressure again starts decreasing and it again becomes 80 mm of mercury. The concept check during atrial filling: is pressure in the atrium higher or lower than pressure in the superior and inferior vena cava? What causes the atria to contract during diastole? Is blood is pushed only into the ventricles upon contraction or is pushed also into the veins? You are supposed to answer these questions in the Google Classroom. Thank you very much, dear students. In the next lecture, we will study volume changes, JVP, and pressure volume loop dynamics.